the force vector to the neutral axis. So IE, it is this distance over here. Okay, it's this distance. Okay, to the neutral axis, and I'll highlight so you can see this. Okay, and this is the most important thing. Okay, then later on I'll show you a different view where the thing is different now. Now, another thing that a lot of students are confused, why this 150 will be 150 axial over here. And as I said, we have learned this before. Okay, remember we had an example. Okay, we had an example when we were doing eccentric symmetrical bending, right? So we have a structure looking like this. And then we have a coupled load, okay? And where failure will occur at point C, okay? So we are going to analyze what is going on at point C. So at point C, okay, so we just need to sketch half of it. Okay, so now at point C, right? So what we have, I'm just going to draw up to point C. Oh, it's correct, sorry. Right? So at point C, so we know there is a P over here, right? And over here, we will have a P also, right? So this is due to Newton's third law. Okay, action equal reaction, same magnitude, different direction. Okay, and if we, I'm going to construct our neutral axis. So this is our neutral axis. Now, point C is where we are interested in. So this will generate a moment, okay, in the Z direction. So if I were to draw transformation, X, Y, rotation Z, right? So again, we will have to have a counter moment. So this is moment Z at point C, okay? More important, I want to elaborate there's an axial load. So we have seen this before, so that's why we have to put the 150 as axial load as axial load relative to element H and K. Okay. So as I said, a lot of times a lot of times, not just in this course. Okay, I've done consulting. A lot of times engineers forget to move that load downwards. Okay. Okay. So we have done analysis on the 150 pounds. Anything else? No. The rest, okay, the rest are all crosses and dots. Okay, all these are hold on. All these are all the crosses and dots. You don't Eugene, what am I doing? All these are your crosses and dots. You don't analyze them yet. To analyze them, you have to draw a different view. Okay. Before I go on, I want to see the chat. Anyone, any questions so far? No. Okay. Anything, just stop me. Okay. So we are going to look at a different view now. So I'm going to copy this diagram. Okay. So now a different view we're going to do is we're going to look at XZ plane now. Okay. So view. So we're going to look at X. Hey, come on. we're going to look at X.
Oh, so Eugene,
Yes.
I have a question about the neutral axis.
Yes.
So when we're doing the test, so we also make a sketch for the neutral axis, or we need to determine the position of the neutral axis.
You just need to do a sketch always.
Oh, okay, all right. I thought we
Okay.
need to do
Because
the
this
same.
question, I will never ask you to find the exact question of the neutral axis. You have to sketch, then you can analyze. If you don't sketch, you cannot analyze.
All right, I got it. Thank you.
Okay. So we are going to look at exact plane now. Okay. So now we're going to draw. So, draw circle, seriously. So we're going to have 4, 4, 6. Okay. Then we're going to have, there's a circle down here. Okay. Then I'm going to sketch the position of the neutral axis. Right. And then we are going to sketch our element. So this is our element H. This is our element K. Then we have a load coming down or pushing up at 50 pounds. Another load pushing at 150 pounds. Over here, we have 200 pounds, right? And then we have a force pushing here at 150 pounds. So by looking at this view, right? Let me string this down. By looking at this view, right? It is so clear that the 150 pounds will induce an axial load, yes or no? Right? Which you have done the analysis already, which you have done over here already. Okay. Okay. So from this view, now we are going to analyze. Okay. So we're going to do positive coming down. Okay. And we are going to look at the shear force in the z-axis. Okay. So positive is coming down. Okay. I just declare that you can say positive is going up. Fine. Okay. So you have 200. Okay. 200 minus 150 minus 50. So this is equal to 0. Okay. And then you have, I do apologize, this is rotation about y. Okay. So the next thing is we're going to take the moment about y. Okay, in the y-axis. Okay, so I'm going to declare that going anti-clockwise is positive. Okay. So as I said, all these are I'll put down here. Moment taken from the element. Okay. So we know that the 150 will be multiplied by 4 because there's a perpendicular distance, plus by 50 multiplied by 10 minus by 200 multiplied by 10. Okay. Right. Now, what you see now, okay, let me calculate the value first. So this is equal to 150 times 4 plus by 50 times 10 minus 200 times 10. is equal to minus 900 pound-inch, right? So minus 900 pound-inch, what does it mean? So if you want to put this as 900 pound-inch, you have to flip the rotation, okay? So we know that over here, this is your moment about your y, okay? So let's analyze what's going on the element first, okay? So if we apply the formula stress X is equal to moment about Y over IZZ multiplied by the distance Z. Oh, no, sorry. What am I doing? IYY multiplied by Z. What we realize is element H, the stress is equal to 0 because it's at what? It's at the element H is at the neutral axis, and element K is equal to negative because the head of the shear force vector or the bending moment vector is compression. The tail end is what? Tensile. Okay, so we get that. Okay, now for this case, the forces, the force vector, all this, right, are perpendicular to the what? Neutral axis. Okay, so this is our neutral axis. So when this is the case, number 7 rule that I think is really, really important is when the force vector is perpendicular, it is perpendicular to the neutral axis, right? The distance is between the force vector to the element now. Okay, right? So it's different, right? So when the force vector is perpendicular to the neutral axis, right? The distance is between the force to the element. Whereas the one earlier, right, shown down here, when the force vector is parallel to the neutral axis, the perpendicular distance is between the force to the neutral axis. Okay, so this is for the moments. Okay, when you are taking a moment. Now, what I'm doing now is like a summary sheet. You can see that, right, from the lecture, how you can summarize the lecture into different into notes that will help you when you study for your term test or your exam. And you should do this for not just this course, any courses that you take at McMaster. Okay, this is really, really useful. Okay, so anything else to analyze? That's it. Okay, we have nothing else. Then we have to look at another view. Okay, we have to look at so-called the YZ plane. Okay, so now we are going to look at the. Let me copy this image. Okay, then we are going to look at the YZ plane. So now I'm sketching the YZ plane. And then right hand rule. This is rotation about X. Okay, so I'm just going to sketch this. Not the best sketch, but it will do. Okay, and then we have a chain line down here.